Hi dear students, welcome back. So we were doing the IUPAC nomenclature of carboxylic acid. We have another two examples. We will just see how to number it and put the name. Okay, so I hope you could see the first example here. So it's a bond line notation given here. So first thing is identifying whether any functional group is present or not. So I could see here this is a carbon atom. So in this carbon atom double bond O and OH is there, correct. So this is carboxylic acid group. So I can say from here I should start selecting the parent carbon chain. Now I can go in this way 1, 2, then 3, 4, 5, 6, 7 because I should include the double bond, maximum number of double bonds in my parent carbon chain. So my parent carbon chain should be which one? This should be this one. Okay. So this is my parent carbon chain. So I have chosen my parent carbon chain. Next thing is numbering. So I know that the minimum number should come to the functional group. So 1, 2, 3, this should be 4 and this should be 5, this should be 6 and this should be 7. Okay, I hope the numbering is clear for you. Now we need to follow the format. So what is the format to be followed? So first comes the second degree prefix. So second degree prefix is a substituent. At the fourth position there is a methyl and at the second position there is a methyl. So I can say how to write, tell me 2, 4, okay, 2, 4 hyphen, okay, dimethyl, then comes the 1 degree prefix. It is not a cyclo compound, so 1 degree prefix is not applicable. So in that case the word root, 7 carbon atoms are there, so the word root is hept, correct, hept. At the 6th position there is double bond, so hept 6n, correct, hept 6n. Then comes the first position, there is a oic acid, 1 oic acid. Okay, so my answer is 2, 4 hyphen dimethyl hept 6n 1 oic acid. So this is the answer for this question. Now let us discuss the next question. So here also I am looking for the functional group. So I could see here C double bond O OH. So this is the functional group. So I should start selecting the parent carbon chain from here. Then I know that I will go like this 1, 2, 3, 4, 5, 6, 7. So that is my parent carbon chain. Okay, so I have chosen that. Okay, now some students may feel doubts, sir, here cyclo compound is there, why you have not considered it? Very simple answer, functional group is attached to the linear chain compound, so that's the reason why this is the parent carbon chain. In this case the cyclo compound will behave like a substituent. Okay, so what should be the numbering? 1, 2, 3, 4, 5, 6, 7. Now how should I name it? Tell me second degree prefix, that is 5 hyphen cyclopropyl, correct. Then 1 degree prefix is not applicable because the parent carbon chain is a linear compound. Then comes the word root, that is 7 carbon, so it is hept, correct, hept. Then okay, here I made a mistake. At the second position also there is a substituent is there, so I can write that also. So 5 cyclopropyl, then hyphen 2 methyl, okay, 5 cyclopropyl 2 methyl hept. We will see all are linked through single bond, so there is no issues. So I can say heptane. At first position 1 oic acid. Okay, so this is the way you should name the compound if COOH or carboxylic acid comes in the parent chain. Okay, I hope you understood. We will go to next examples. Hi students, in this question there is a change is there. I made a slight mistake. It is not like this. In the question paper it is given like this only. Okay, so this is okay. So that is methyl, both are methyl. So that's the reason why it is written like 2, 4 dimethyl. So earlier I have written ethyl, that is not correct. So 2, 4 dimethyl hept 6n 1 oic acid. Okay, here it is correct, 5 cyclopropyl and 2 methyl. That's why alphabetically which substituent will come first? The cyclo compound will come first. So that's why 5 cyclopropyl 2 methyl heptane 1 oic acid. So it's clear, right? Okay. Hi dear students, so next we are going to deal with the IUPAC nomenclature of esters. Okay, so you know that esters are sweet smelling, actually fruit smelling. Okay, we have learned that in many a times actually. So what is the functional class name of esters? You should remember this, it is alkyl alkanoate. So I will explain with the functional group, that is RCOOR is the basic form, basic representation of esters. So here what is alkyl stands for? The one that is linked with the O. You could see here O. This whatever it is linked with the O, that linkage, it should be always an alkyl group, and that is called alkyl here. Okay. Now next term here is, what is the next term used here? The next term used here is alkane. Okay, alkane. So from where this alkane will come? The part which is connected to carbon, count the number of carbon atoms here. So suppose if it is 2 means here instead of alkane what will come? Ethane. If it is 3 carbon atoms it will come as propane. If it is 4 carbon atoms it will come as butane. Okay, and similarly here R dash can be ethyl, methyl, anything. So whatever that is linked with the oxygen atom, that is the alkyl. Then the suffix used here is if it is esters, the suffix used here is OAte. Understood? So we could see one example here. So here first thing for naming here is I will look for oxygen that is connected to what is connected to oxygen. So I could see here methyl is connected to oxygen. So I will start with methyl. Okay, methyl. Then what should I do? Then comes alkane. For that I will select the parent carbon chain. So the parent carbon chain has how many carbon atoms? 1, 2, 3, 3 carbon atoms. So I will use the term alk here is prop. So I will use propane. Okay, so alkane is complete. That is propane here. So methyl propane. Then we know that it is an ester. So use the term OAte. So the answer is methyl propane. Some people used to say methyl propane 1-OAte. That is also correct. Or we can say methyl propanoate. Correct? So I hope you understood. Very important is whatever linked with oxygen atom is the alkyl group here. Alkane here is the one that is including the carbonyl group and the R group. Count the number of carbon atoms, that is the alkane. And why AN is coming? Because all are linked as single bond. Then OAte is the suffix used. Okay. So I hope you understood. We will see some more examples for esters. Okay. So let's see the example. Okay, so the first example here you could see first identifying the functional group. So you know that double bond O is there, another O is there, that is COOR. Correct? So it's an ester basically. So what is the format of ester? Alkyl alkanoate. So first comes whatever be the, we know the format. First is 2 degree prefix, 1 degree prefix, then word root, 1 degree suffix, 2 degree suffix. Before that only what will come? Alkyl will come. Then only this format will come. Please remember that. Otherwise many students will make mistake there. So first thing is alkyl. Alkyl is what here? Methyl. So I can write methyl here. Okay. Then I will start counting. So this is my parent chain. Okay, coming here. So I know that substituent is here. So maximum substituent. So 1, 2, 3, 4, 5. So this should be my parent chain. Correct? So 1, 2, 3, 4, 5. Now tell me where are the 2 degree prefixes located? At position 2 there is an ethyl group, and at position 3 there is a bromo group. So who will come first? First is bromine alphabetically. So I can say methyl, okay, then 3 methyl, 3 bromo, correct? Then 2 ethyl, methyl, 3 bromo, 2 ethyl, 3 bromo, 2 ethyl. How many are there? 5 carbons are there. So I use the term word root pentane. All are connected as a single bond. I use the term pentane. Okay, and we know the suffix used, it's an ester. So the suffix used will be OAte. So my answer is methyl, 3 bromo, 2 ethyl, pentane, 1 OAte or pentanoate. Both are correct. Now we will go to the next example. Okay, I hope you could see here. So here also I could see COOR. So R here, the alkyl group is methyl. So I will start with writing here methyl. Okay. Then I will put the numbering here. So I know from here I need to start. So here the since the functional group is attached to the side chain, so this becomes my parent carbon chain. Okay, this becomes a substituent. So 1, 2, 3, 4. Correct? Why? Because the functional group is attached to the side chain. Okay, now how I can write methyl at second position there is a cyclohexyl group. Methyl 2-cyclohexyl. Correct? Methyl 2-cyclohexyl. Then what I can write, how many are there? 1, 2, 3, 4. So butane, they all are linked as single bond, that's why butane OH. Either you can write butane 1-OH or butanoate. So methyl 2-cyclohexyl butanoate, and this one is methyl 3-bromo 2-ethyl pentanoate. So I hope you understood. So we can see even one more question from this area for your better understanding. Okay. Hi students, so let's see the next examples. So here also the first example you could see, here the functional group COO, so O linkage I could see, so the alkyl group here is methyl. So I will start with writing methyl. Okay. Then in the last video I forgot to tell one thing. So after this methyl you don't want to put the hyphen, that is not required actually. Okay. So methyl, then what? We will look for the parent chain. So starting from here, then it will go like this, it will go like this, because there is a double bond here, so I should include that. So this is my parent chain then. Okay, so 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, and this is 8. Correct? Now starting with the 2-degree prefix, at second position there is methyl and sixth position there is methyl. So I can say methyl 2,6 diamethyl. Okay, methyl 2,6 diamethyl. How many carbon atoms are there? 8. So I can say oct, and we know that 7th position it is linked through double bond. So oct 7N. I know that at first position the ester 1-OH. Okay, you don't want to mention this one, you can write inoate or N1-OH. This like this you need to write. So methyl 2,6 diamethyl oct 7N 1-OH. I hope you understood. Same thing, this is the what actually, this is my 2-degree prefix. Correct? This is my word root. Correct? And what is this? This is my 1-degree suffix, and this is my 2-degree suffix. I hope you understood. So this is the way we need to write it. Now coming to the next one. Okay, little bit interesting. Again, to the oxygen group there is one carbon, there is another carbon, so it is an ethyl group. So I can say I will start with the name ethyl. Okay, ethyl. Then I know from this carbon atom the parent chain will come. So from here, in which direction I need to go? 1, 2, 3, 4, 5, 6. So I will go like this. Okay, so this is my parent chain. So 1, this is 2, this is 3, this is 4, this is 5, this is 6. Now I know that at second position there is an ethyl group, and at fifth position there is bromo. So who will come alphabetically first? Bromo. So I can write ethyl 5-bromo, ethyl 5-bromo, then 2-ethyl. Correct? Second position ethyl group is there. So ethyl 5-bromo, 2-ethyl. Okay. Then how many are there? 1, 2, 3, 4, 5, 6. So 6 means hex. Correct? And all are linked through single bond. So it is hexane. Then I can add the suffix OH, hexanoate. Either I can add hexane 1-OH or hexanoate. Both are correct. So I hope you understood the idea how to do the naming for esters. So we will go to the next functional group. Okay. So next we are going to discuss the nomenclature of anhydrides. Okay. So anhydride, you could see the functional representation is like two carbonyl groups linked through oxygen atom. So for your understanding, let me say how basically anhydride is obtained. Please listen, whenever you have two acids are there, C double bond of OH, okay, this is another C double bond of OH. So whenever two acids combine together, or when you are trying to react with two acids, what will happen here is the water elimination will happen. Okay, on heating, water will get eliminated. Okay, so what will happen here? So C double bond O, okay, then OH is gone, then one oxygen atom, then that oxygen atom is linked to another carbon, and there is O and there is carbonyl group. So this is basically how you obtain an anhydride. So please remember, whenever you heat two acids, water elimination will happen and anhydride formation will occur. This we are learning in the one of the organic chemistry chapter. This is just for your understanding. So please remember, whenever two OH groups, when two carboxylic acids comes in the nearby carbon atoms, what will happen? If there is a heating happens, there is always a possibility of elimination of water, and what formation will happen? Anhydride formation will happen. Okay, now here the suffix used for anhydride here is oic anhydride. Okay, and the standard name usually used is alkanoic anhydride. So this can be varying. I will tell how it is. Usually it is alkanoic anhydride and there is no prefix. Prefix means it will not behave like what? A substituent in normal cases. Okay, that's the reason why there is no prefix. And this is same in the case of esters. For esters also there is no prefix is there. Okay, so let's see what are the two different types of anhydride. That is very important. So basically we say there are two types of anhydrides are there and their nomenclature is also different. Okay, so one is called symmetrical anhydrides. One is called symmetrical anhydrides. Okay, symmetrical anhydrides. And let's see some example from symmetrical anhydride. So maybe I will start with this one. H C double bond O. Okay, O C double bond O H. So how will you name this compound? So what is the basic way is identify the number of carbon atoms. So here you can see one carbon atom here and another one carbon atom here. So whenever it is symmetrical, symmetrical means the area after this oxygen atom should be same as the area before this oxygen atom. So if I look at this area and if I look at this area, both should be the same. In that case, we use only one time the term. That means here only one carbon atom is there. So we use the term meth. Okay, we know the common name is what? Alkanoic anhydride. So here we use methanoic anhydride. Understood? Why? Because only one carbon atom is there and both are similar. In that case we use the term methanoic anhydride. Now let me give you another example, then it becomes easy for you to understand. Okay, so let's see something like this. CH3 C double bond O, O C double bond O, CH3. These are all different representations. Okay, so here also I can see from this oxygen atom, this is symmetrical in nature, above and below. Now we know that how many carbon atoms are here? Two carbon atoms are there. So two carbon atoms means what is the term? Eth. So I can say ethanoic anhydride. Ethanoic anhydride is the term used. Understood? So let's see another example. So now I hope you understood. So let's see this one also. Okay. Can you name this compound? Now if you see here, from here also I am seeing the symmetry. So 1, 2, 3, 1, 2, 3. So it's symmetrical again. So what should be the term? I can say 1, 2, 3. 3 carbon atoms are there on both sides. So it should be prop. So I can say it is propanoic anhydride. Okay. So I hope you understood. So we will go with the next class of anhydrides that are called unsymmetrical anhydrides. Okay. So we will see next one, that is unsymmetrical anhydrides. So I can write here unsymmetrical anhydrides. So and we will see how to name that compound. Okay, unsymmetrical anhydrides. So starting with the example, I will give you this one. H C double bond O, O C double bond O, CH3. So let's see here. So if I try to divide this, I could understand both half are different. So in this case, what you should do, you should count the carbon atom here. So here 2 carbon atoms are there. So I can say eth. Here also 1 carbon atom, then meth. So who will come first alphabetically? I know that eth will come alphabetically. So we will name it like ethanoic. Here methanoic, methanoic anhydride. Understood? Since it is derived from 2 different types of acid, we can say one is methanoic acid I have taken, and the other one acetic acid or ethanoic acid I have taken and heated. So I got ethanoic, methanoic anhydride. Okay. So let's see another example. Okay. So can you name this compound? So here if you see, I could see again this is not a symmetrical anhydride. So I am counting the carbon atom 1, 2, 3, 4. Here 4 are there. 1, 2, 3. Here 3 are there. So there is butane and there is prop. Who will come first alphabetically? Butane. So I can say butanoic, propanoic anhydride. So this is the way we need to usually give the IUPAC name for anhydrate. So I hope you understood there are symmetrical and unsymmetrical anhydrates are there, and how an anhydrate is formed. Whenever you take 2 carboxylic acid group to nearby carbon atoms, if in a cyclic ring, if it is near to the nearby carbon atoms are occupied by COOH, then if you are heating, the water elimination will happen and anhydrate formation happen. Or you can take 2 individual molecules of linear carboxylic acid and mix them and heat it. It will eliminate water and form the anhydrate. Okay, so I hope you understood how to name anhydrates. So we will go to the next class of compounds. Okay. Hi dear students. So today we are going to learn next topic, that is the IUPAC nomenclature of acid halides. Okay. So we have first learned carboxylic acids, then we learned anhydride, we learned esters, then comes acid halides in the priority table, correct? So in acid halides you can see the suffix, okay, or how it is represented basically COX, correct? So here carbonyl group is there, and why halide is coming? Because X indicates halogen. So X can be what actually, what and all possibilities for X? This X can be either fluorine, or it can be chlorine, or it can be bromine, or it can be iodine. Understood? So the X can be fluorine, chlorine, bromine or iodine. So together we call the name halogens, correct? So we say acid halides. Okay. Now the important thing. So we have this acid halide also, if you look into it, there is a carbonyl group and this carbon atom is there. So we can say it's a carbon containing functional group, correct? So in this case there are 2 possibilities. If carbon is part of the parent chain, that's why it is shown in brackets, okay. So if carbon is part of the parent chain and if it is included in the parent chain, we use the suffix oil halide. What is that? OYL, oil halide, okay. Now in this case no prefix is there, prefix is not applicable. What does that mean? It means that if carbonyl if acid halides is there and its carbon atom is included in the parent chain, then it will behave like the then it will behave like a senior most functional group. There is no prefix, it will not behave like a substituent. Suppose COX, in this case you can see this carbon atom is not included in the parent chain. How you know that? Because no brackets is kept here. Brackets are there means that carbon is included. So in this case no carbon atom is not included in the parent chain means what should be the suffix? It should be carbonyl halide, because carbon atom is not included. So in the name we will mention that is called carbon is coming here. Understood? So carbonyl halide will be the suffix used, that is the 2 degree suffix we are using. In this case prefix is there, that means whenever CO carbonyl halide is there, along with that some carboxylic acid is coming. We know that carboxylic acid has the highest priority, right? In this case the carbonyl halide will behave like what actually a substituent. In that case we use the prefix what? Halocarbonyl. What it is? Halocarbonyl. Okay. Now let's see one example here. CH3, CH2, COCl. So here I can say my parent carbon chain is what actually? This is my parent carbon chain, correct? Carbon atom is included, correct? So how will you put the name? Now tell me, it is oil halide. So I know the parent it is starting with 3 carbon atom. That means the word root is 3. Word root means 3 is there, means it should be prop, correct? Prop. Now I know that all these are linked through single bond. That means propan. An will come. Propan. Now if I number it, I know from here I should number it. So propan. Okay. Propan 1. We know that what is the extension? OYL. Oil halide. Understood? So answer should be propan oil. Either we can say propan oil halide or propan 1 oil halide. This should be the answer. So I hope you understood. Very simple. If carbon atom is included, it is oil halide. If carbon atom is not included, in that case we say carbonyl halide. One example I can create here. Example for that one is something like this. We have seen similar examples earlier. Okay, here you could see. This is one example I am creating for you. So in this case, can you tell me what is the name of this compound? Here I cannot include this carbon in the parent chain because there is only one carbon here. So I cannot form a parent chain here also. In this case, the ring will behave like a what? Parent. So I can say, what should be the name? Cyclohexane. What should be added? Carbonyl halide. So I will write down here, okay, cyclohexane carbonyl halide. Okay, it should not be halide, it should be too specific since chlorine is given there. So carbonyl chloride. Understood? So cyclohexane carbonyl chloride. Okay, there can be other possibilities also. I can write many examples. Here CH2 comes means then that should be the parent chain. Then cyclohexane will become like a substituent. We say 1 cyclohexane, like that you can create examples. So I hope you understood. This is cyclohexane carbonyl chloride and this is, okay, here also I should say it chloride. Propanoil, not halide. So here chlorine is mentioned clearly. So it should be chloride. Okay. So the answer should be propan 1 oil chloride. So I hope you understood. If you have any doubt, get back to us. So we will take one example from this section. Hi students. So let's see some examples of IUPAC nomenclature for acid halides. So the first one, it's a previous NEET question also. Okay. So you could see here, this is C double bond O, then Cl is there. So that means acid halide is a functional group here, correct? Now I need to know that I can choose my parent carbon chain. So I should include this because this is a functional group that contains carbon. So how can I choose the parent carbon? So I can choose here. So the longest path I should choose. So this is longest. This is coming. There is no double bond or anything. So this is my parent carbon chain. Okay, correct? So this is my parent carbon chain. Next thing, I should do the numbering. So I know that the minimum number should come to the carbon of the functional group. So 1, this should be 2, this should be 3, this should be 4 and this should be 5. Correct? So tell me how to do it. First comes the 2 degree prefix. 2 degree prefix is present at position 2 and 3. So both are free end. So that means methyl group. So at 2, 3, what is present? 2, 3 hyphen dimethyl, correct? Now tell me 1 degree prefix is not applicable since it is not a cyclo compound. And what is the word root? There are 5 carbon atoms, so the word root should be pent. How the 5 carbon atoms are linked? They are linked through single bonds, so I can say it is penten, correct? And I know that there is 2 degree suffix is there because there is a functional group. So at what position? At position number 1. So I can say penten 1. We know the extension or the suffix if carbon atom is included. What is that? Oil, correct? Oil halide. So here it is chloride. So I can say oil chloride. So what is the name of this compound? 2, 3 dimethyl pentanoyl chloride or penten 1 oil chloride. Both are correct. Now coming to the next example, it's very simple example. Now tell me, here also the functional group is COCl, so I can say my parent carbon chain is this one, correct? How many carbon atoms are there in the parent carbon chain? 2 is there, so I can use the term eth, correct? And all are linked through single bond, so I will say ethane. So numbering 1, 2, so ethane 1 oil chloride, correct? So that means ethanoyl chloride, or I can say ethanoyl. There is no substituents, there is no 1 degree prefix is not applicable. So the answer should be ethanoyl chloride or ethane 1 oil chloride. Okay, so this is the way you need to name what actually acid halides. Every time I have put chlorine here, it can be bromine coming. In that case, what we say bromide. It can be fluorine coming. What you will say fluoride. If it is iodine, you will say iodide. Okay. So I hope you understood the IUPAC nomenclature for acid halides. Now we will go to the next group. Okay. Hi dear students. So next we are dealing with the IUPAC nomenclature of amides. Okay. So coming to amides, the functional group here is CONH2. You could see here chlorine is replaced by amino group NH2. Then we say it is amides. Okay. Now the suffix, as I told, if the carbon atom of the amide group is included, we use the suffix amide, A-M-I-D-E, amide. And there will be no prefix if the carbon atom of the amide is included in the parent carbon chain. That means when this carbon atom is included in the parent carbon chain, and this amide group will not behave like a substituent. Understood? Okay. Now the second case is when amide group, where the carbon atom of the amide group is not included in the parent carbon chain. There can be case like that. I have shown you in the previous case also. So in that case, what we will say? We will say carboxamide. Carboxamide, that is the suffix name. Understood? Carboxamide. In this case, if suppose CONH2 behaves like a substituent, the prefix used will be what? Substituent, in that case the prefix used will be carbamoyl, C-A-R-B-A, carbamoyl. Okay, so please remember, if carbon atom is included, we use amide, and if carbon atom is not included, we use the suffix carboxamide. In case this CONH2 behaves like a substituent, in this case if carbon atom is not included, then we use the term carbamoyl. If carbon atom is included, then it will not behave like a substituent. Okay. Now here, what is the functional class name? Alkyl alkanamide. This is for your easy understanding. So alkan means how many carbon atoms are there? Amide. Then why this? From where this alkyl is coming? Please understand, sometimes this NH2 is there. One H may be replaced by some alkyl group. In that case, that particular alkyl is what it is shown here. Alkyl, then remaining normal case, alkan amide. Okay. So here amide is the suffix. Alkan, it is a parent carbon chain. How many carbon atoms are there? This alkyl is optional. It will come sometimes only. Sometimes when NH2, one of the H is replaced by methyl group. Understood? So let's say let's start with one example, then you will understand this more easily. Now if you see into this example, you can see here my parent carbon chain CONH2. So this carbon atom is included in the parent carbon chain. I am selecting it, correct? Now here I am numbering it, lowest number 2, 3. Now tell me the parent carbon atom has how many parent chain has how many carbon atoms? 3 are there. So I will use the word root prop. Correct. So you can see here alkan, so that is prop, then alk has come. Now all are linked through single bond, so I can use AN, propan, correct. Then first position, propan 1 amide. Either I can say it like propan 1 amide or propanamide, both are correct. Understood? So we will see more examples for your easy understanding. Let's take one example like this. Okay. Now you might have seen this many a time with other functional groups. Can you tell me the name of this compound now? You could see here, 1 minute, here there is no double bond. Okay, there is no double bond, just CONH2 is added. So what can be the name of this compound? I know that this is a carbon containing functional group, but there is no way I can include this in my parent carbon chain. So I can say cyclohexane, correct? Cyclohexane. If carbon atom is not included in the parent carbon chain, what is the suffix used? Carboxamide. So I can say cyclohexane carboxamide. Understood? So this is the way we need to name the compound. Now we will see more examples from this particular class. Hi dear students. So I hope you could see both examples here. So let's try to see how to solve this. So the first one, you could hear C double bond O NH2. So instead of one hydrogen, another methyl group is added by replacing one hydrogen atom. In this case, as we learned, what should be the name? Alkyl alkanamide, correct? So let's say my parent carbon chain is this one here, correct? So I should start numbering 1, 2, 3, correct? So I know that it should be alkyl first, then this one alkanamide. So alkyl means, tell me which is the alkyl group present here? Methyl. So since it is coming from the nitrogen, usually in standard notation we say N, okay, hyphen methyl. We used to say like this. This is called alkyl. We know that the functional class name is what? Alkyl alkanamide, correct? Alkanamide. So this is the alkyl that is coming. So here I can say N-methyl, okay. Now alkan, what is alk part here? Alk word root. How many are there? 3 carbon atoms. So I will say prop. Now all are linked through single bond. So I will say propan, correct. At first position we have amide. So propan 1 amide. Understood? So this is the way we used to name the compound. Either we can say N-methyl propanamide or N-methyl propan 1 amide. That is also correct. So this is a functional class name. If you remember the functional class name, it is very easy to name it. Otherwise we will forget how to do this and all. So this is very simple, N-alkyl. Some students used to ask a doubt, sir, what happens if this H is also replaced by another methyl group? In that case we need to say that 2 times we need to say N. If both are methyl means I can say N, N dimethyl. Understood? Otherwise we say N, N. First we will say alphabetical, who will come first. If it is ethyl we say NN, ethyl, methyl, then corresponding alkanamide. Understood? So this is the way we used to name this. Now we will go to the next example. So in the next example, either here we can directly see CONH2 is the functional group, amide. So I can select my parent carbon chain. So this is my parent carbon chain. Correct? So just count the number. So 1, 2, 3, 4, 5. So I will start from here. 2, 3, 4, 5. Now this is a direct example. So word root, how many are there? Pent. Correct? First position, pent 1. Sorry, pent. Then all are linked through single bond. So we say pentan. First position we have amide. So pentan 1 amide or pentanamide. Both are correct. Okay. So I hope you understood the concept. Now we will go to 2 more examples. So next we will do this question. Now listen to the first question. This is very good question and I will say this is an important question. Why? Because you have a cyclohexane ring is there and CO amide group CONH2, one H is replaced by ethyl group that is present outside. So here we cannot form a parent carbon chain. So here many students used to ask me a doubt, sir, here 2 other carbon atoms are there, right? So why can't we form a parent carbon chain like this? I will just draw like this. So whether it is possible? No, because the parent carbon chain should be long and continuous. If I am doing like this, there is a nitrogen atom coming in between. That is not possible. So whenever you choose, it should be a continuous parent carbon chain. So that's the reason why you cannot choose this as my parent carbon chain, even though functional group is present outside. So in this case, again, what is a functional parent carbon chain? The cyclohexane is the parent carbon chain. So I know that first one, again H is replaced by one alkyl group. So first I will say alkyl, then only alkanamide will come. So alkyl means what will come here? N, correct, hyphen, who is the substituent? Ethyl. So I can say N-ethyl. So alkyl part is over, correct, alkyl part is over. Now we know that how to name this compound. we know that this is coming, this carbon atom is not included in the parent carbon chain. So we use the term cyclohexane. Cyclohexane. What is, if it is not included, what is the suffix we are using? Carboxamide. So N-ethyl cyclohexane carboxamide. Understood? So why I am using, it's again, don't, if you remove this, it is CONH2, that is what cyclohexane carboxamide. Nothing, I put one, instead of one H I put CH2 CH3, then it becomes what? N-ethyl cyclohexane carboxamide. Okay, so it is clear, I hope. Okay, now let's see the next one. Here, what should be the name of this compound? Here you can see both H is replaced by methyl group, and this is again amide group with both H replaced by methyl group. So in that case, again alkyl part will be what? I can say N, N hyphen dimethyl. So this indicates the alkyl part here. Then remaining what will come? Alkanamide. So N, N dimethyl. I can say this is my parent carbon chain. Correct? So 1, 2, 3, 4. So 4 carbon atoms are there. So 4 carbon atoms are there means the word root is what? But. All are linked through single bonds. So I can say butane. First position you have the amide. Butane 1 amide. So I can either say NN dimethyl butanamide or NN dimethyl butane 1 amide. Both are correct. Okay, I hope you understood. Very, very important questions, these things. So please try to understand, and if you have any doubt, please clear it in doubt clearance session. Okay. Hi dear students, few more examples. So let's try to see the first example, how to do the question. So here also first I am checking which is a functional group connected. So the functional group here is CONH2. Okay, so again I understood it is a CONH2 that is connected, that is amide. So I can say this is my parent carbon chain. Starting from here, I am trying to select the longest possible chain. Correct? So this is my longest possible chain. Now next part is the numbering part. So numbering, I know this should get minimum number 1, 2, 3, then 4, this one will 5, and this one will be 6. Now how to put the naming? First who will come? 2 degree prefix. 2 degree prefix means 4th position bromo is there, 5th position chloro is there. Who will come alphabetically first? Bromine. So I can say 4 hyphen bromo, correct? 4 bromo, then 5th position 5 hyphen chloro. So 4 bromo, 5 chloro. Now the word root. How many are there? 6 carbon atoms. So it should be hex. All are connected through single bond. So I will say hexane. Correct? Now tell me what is a functional group? Amide. So suffix is amide. So hexane 1 amide. Either I can say it like that or hexanamide I can say. So my answer is 4 bromo 5 chloro hexanamide or hexane 1 amide. Now let's see the next example. So here if you see in the next example you can see a double bond here. So that means this should be a carbon atom, and this is another carbon atom, and this is another carbon atom. And who is the functional group present here? CONH2, again amide. So I am choosing my parent carbon chain. I have chosen this. Now I know that try to include the maximum number of multiple bonds. So this should be my parent carbon chain. Correct? Now I should number in such a way that the functional group get the minimum possible number. So this should be 1, and this should be 2, this should be 3, and this should be 4. This carbon atom should be 4. Correct? So don't forget this third one. Most of the students will forget that. Okay. Now again, what is the 2 degree prefix substituent? At second position there is methyl group is there. Anything else? Nothing. So I can say 2 methyl. Correct? 1 degree prefix is not applicable. Why? Because it is not a cyclic compound. And word root, how many are there? 4 carbon atoms. So I use the term but. Correct? And I know that but, it is linked by triple bond at position number 3 and 4. So minimum number is 3. So I will use but 3yn. I cannot put E. Why? Because there is a 2 degree suffix is there. Functional group is there. So but 3yn at first position 1, I can say amide. So this is the answer. So 2-methyl but 3yn 1 amide. If it is double bond, we say but 3en. If it is double bond, triple bond, we use yn, 1 amide. Okay. So we will do one more example and wind it up. So the next example is, try to do this one. Okay. CH2 C double bond O NH2. We have done examples like this, but it is different functional group. Now here you can see functional group is CONH2, but that alone is not present outside the ring. There is another CH2, so you can form a parent carbon chain here itself. Understood? If it is only one CONH2 alone is there, then the ring will become the parent carbon chain. Very, very important example. That's why I am again explaining. So this becomes a parent carbon chain. So the numbering will be 1 here and 2 here. So at second position there is a substituent. So this will behave like a substituent, that is 5 carbon atom. 1, 2, 3, 4, 5. So it's a cyclopentyl. So how I can say first 2 degree prefix will come, that is at second position 2 cyclopentyl. Correct? Then 1 degree prefix is not applicable because the parent carbon chain is linear. Then word root, how many carbon atoms are there? 2. So we use the term eth, and they are connected through single bond. So we use the term ethane. Then at first position there is amide. So ethane 1 amide. Understood? Very, very important examples. So I hope you understood. Now we will go to the next class of organic compound. Students, so next we are going to discuss the IUPAC nomenclature of cyanides. Okay, so coming to cyanides, this is important little bit, I will say. So the functional group here is CN. Okay, cyanide. Now, as discussed earlier, as you have seen in the priority table, if carbon atom of the cyanide is included in the parent carbon chain, usually we should include that. In that case, we use the suffix what? Nitrile. Okay, and there will be no prefix if carbon atom of the cyanide group is included in the parent carbon chain. Okay, that means if carbon atom is part of the parent carbon chain, there will be no prefix. That means in that case, cyanide group will not behave like a substituent. Now, the next case, the suffix is carbonitrile when the carbon atom of the cyanide group is not included in the parent carbon chain. So in that case, we use the term suffix is carbonitrile. Very simple, carbon is not included. That's the reason why carbo is introduced. Understood? So it should be carbonitrile. Okay, what is the prefix? If the cyanide group behaves like a substituent, sometimes it comes with carboxylic acid, then cyanide group will behave like a substituent. In that case, we use the prefix cyano. Understood? Cyano. The most important thing here is the functional class name is alkane nitrile. Here the important thing is E. You can see here, whenever you are attaching nitrile or 2 degree suffix to the word root or 1 degree suffix, this E is not removed. In normal cases, we used to remove the E, but in the case of nitriles, we will not remove this E. If it is single bond, we say ane. If it is double bond, we use ene, and if it is triple bond, we use wine. We will not remove E in the case of cyanides. Okay, now let's see one example. CH3, CH2, CH2, CN. So how will you name this compound? So I can say my parent carbon chain. So it's a carbon containing functional group. So I will say this is my parent carbon chain. Correct? Now if you see the parent carbon chain, you can see 1, 2, 3, 4. It's a 4 carbon. So 4 carbon means what it should be? 4. Alk should be but. Word root should be but. And all are linked through single bond. So I will say butane. Understood? Butane. Then comes what? 2 degree suffix, that is cyanide group. So we use nitrile. Nitrile. So the answer is butane nitrile. Please don't remove the E. Some students will make a mistake. They will say butane nitrile. It is wrong. It is butane nitrile. Understood? So we will see more examples from cyanides, and we will try to do that. Okay. Hi students. So next we see some examples of naming for IUPAC nomenclature for cyanides. So coming to the first question, you can see here how the cyanide is even represented actually. So you know that this is what actually carbon. So this should be cyanide group, correct? So my parent carbon chain should be which one? So starting, I know cyanide is a functional group connected here, so this should be my parent carbon chain. So coming from here, I can go in this way or this way. I know that this is the longest, so I will choose this one as the parent carbon chain. Correct? Now tell me how to number it. So I will put the least possible number to the functional group 1, then this should be 2, this should be 3, and this should be 4. Correct? So first, who will come? 2 degree prefix will come. So 2 degree prefix is substituent. So we know that at second position methyl group is there. So 2 methyl. 1 degree prefix is not applicable since it is not a cyclo compound. And the word root is 4 carbon atoms. So we use the word root but. Correct? And all are linked through single bond. So we use the term butane. Why I am using E also? Because cyanide is the functional group here. So butane, at first position we have nitrile. Butane 1 nitrile. So either we can say butane nitrile or butane 1 nitrile. Both are correct. So 2 methyl butane 1 nitrile is the correct answer. Okay, now coming to the next one. Here this is will create some little bit confusion because there are 2 triple bonds. Please understand that this is nitrogen and this is carbon. Correct? So this is the functional group here. So this is the triple bond here. Correct? Now I should choose the parent carbon chain. So I know that this is the functional group. So this should be part of the parent carbon. Now I should try to include, if double bond or multiple bond is there, I should try to include the maximum number. So I should include this. So my parent carbon name should be like this. Understood? And we know that here also 1 carbon atom is there. Don't forget that. Okay. And this is also a carbon atom ending in. So we will try to number it. So numbering, I will put 1 here, then 2 here, 3 here, 4 here, 5 here, 6 here, 7 here. So this should be by numbering. Okay. Now how I know that first 2 degree prefix will come. Second position there is a methyl and fifth position there is a methyl. So I can say 2,5 correct hyphen dimethyl 2,5 hyphen dimethyl. How many word root? 7 carbon atoms. So I use the term hept and all are linked through not single bond. There is double bond at the position 6. So I can say hept 6 wine. So here also I should use the term E. Hept 6 wine, and at first position there is nitrile. Hept wine 1 nitrile. Correct? So fifth position and second position substituents. So 2,5 dimethyl, 7 carbon atoms. So we use the term hept. Sixth position there is triple bond. So hept 6 wine. Then why I am using E? Because it is nitrile is the functional group. First position there is suffix 2 degree suffix, that is nitrile. I hope you understood how to do the naming for this type of compounds. So we will do 2 more questions and we will go to the next functional group. Okay, so next we have around 5 questions that we are going to do in a continuous fashion. Okay, coming to the first question, very important, special rule will come to here. Why? Because we have 3 carbon containing functional group connected to the parent carbon chain. Correct? So I have told the special rule, if there are more than 2 carbon containing functional groups are connected to the parent carbon chain, then none of the carbon atoms of the functional groups are included in the parent carbon chain. So the parent carbon chain should be which one? So this one. We will not include this carbon or this carbon. Why? Because there are more than 2 carbon containing functional group attached to the parent carbon chain. Okay, in this case, what is the name? The most repeated question, this one. Okay, so how will you name this? I know that if I do it in any numbering way, this is correct. 1, 2, 3, symmetrical. So I can say 3 carbon atoms. So prop, all are connected through single bond. So I can say propyne, and I know that at position hyphen 1, 2, 3. Then how many cyanides are there? 3 are there. So tri, Tell me nitrile or carbonitrile. Since this carbon atom is not included in the parent carbon chain, we use carbonitrile. So I can say propane 1, 2, 3 tricarbonitrile. Very, very important. So some people used to say 1, 2, 3 propane tricarbonitrile. That is also correct. But most correct is first one word root, then 1 degree suffix, then locants 1, 2, 3. Since 3 are similar, we use the term tri. Then the suffix 2 degree suffix carbonitrile. Understood? Now for the next one, I should rub this. There is no enough space is there. So I hope you have noted down this propane 1, 2, 3 triacarbonitrile. Okay. Propane, since 3 carbon atoms are there, 1, 2, 3 triacarbonitrile. So we will come to the next one, this one. So here you can see it's a carbon containing functional group connected to the ring, and you know that there is no other carbon atoms here. So this carbon atom cannot be included in the parent chain. So the parent here is what? Which one? The ring. We have seen many examples of this type. So what should be the name here? Cyclohexane. Tell me, this carbon atom is not included. So what should be the 2 degree suffix? Carbonitrile. Carbonitrile. Understood? So the name should be cyclo. 6 carbon atom hex, all are linked through single bond, hexane. Since carbon atom of the functional group is not included, we use the suffix. We learned that suffix is carbonitrile. Understood? Okay. So we will go to the next one. So we will do this and we will go to last example. So here you could see here similar example, only thing is there is one extra CH2 group is coming here. So here it can form the parent carbon chain because minimum 2 carbon atoms are there. So in this case this ring will behave like a substituent. So I can say 1, 2 at second position 2 cyclohexyl 2 cyclohexyl. Tell me word root 2 carbon atoms. So we use the term eth, and these are connected through single bond. We use a ethine. Then the functional group is cyanide. Since carbon atom is included, we use the term nitrile. Ethine nitrile. Understood? So I hope it is clear for you. Next we will try to do this question. Are you able to see this? The answer is 2 cyclohexyl ethane 1 nitrile. You can say ethane 1 nitrile or ethane nitrile. Both are correct. Now coming to here, the last example here. So you can see here again this is a carbon atom, correct? So it's a cyanide group. So my parent carbon chain will be which one? Tell me. So since it is present, so here, from here, here, here. This should be my parent carbon chain. Numbering should be, this should be 1 and this should be 2 and this should be 3. And I know that since there are 3 carbon atoms are there, and some students again will ask the same doubt. Sir, here a ring has 4 carbon atoms, but in the side chain there are only 3 carbon atoms. You only taught, right? If ring has more number of carbon atoms, then ring should be the parent. Please understand that if that is applicable if there is no functional group. Suppose the functional group is present in the side chain and there is the length is only 2 also, we should say that as the parent chain. Understood? If cyanide group is present in the ring and suppose the side chain is more lengthier, maybe 60 carbon atoms, then also functional group is attached in the ring, means that ring should be the parent carbon chain. So it depends, the priority is first functional group, then multiple bonds, then comes the substituent. Okay, so that's the reason why it is like this 1, 2, 3. Now tell me what should be the name of this compound. So we know that at second position there is a substituent. That substituent is 4 carbon atoms. So cyclobutyl. So we say 2-cyclobutyl. Correct? In word root 3 carbon atoms. So we use the term prop. 2-cyclobutyl prop. Correct? Then all are linked through single bonds. So we use the term propane. Please write it together when you are writing in the notebook. So 2-cyclobutyl propane, first position nitrile, propane 1 nitrile. Understood? This is for the last one. Okay, 2-cyclobutyl propane 1 nitrile. Now coming to the last question, here you could see only 2 functional groups, cyanides, are connected to the parent chain. and the rule says that if 2 is there, the special rule is not applicable. Then this carbon atom should be part of the parent carbon chain. So this is my parent carbon chain. Correct? So since it's a symmetrical compound, I can do the numbering from here or here. So 1, 2, 3, 4, 5. Correct? So I know that first 2 degree prefix, that is a substituent. So I use the term 3-chloro. 1 degree prefix not applicable since it is not a cyclic compound, and word root 5 carbon atoms. So I use the word root pent, and all are connected through single bond. So I use pentane. Correct? Then I know that at positions 1 and 5 you have nitrile. So pentane hyphen 1 comma 5 hyphen, both are same. So we use the term dinitrile. Since 2 are there and these 2 are similar, we use the term dinitrile. So 3-chloro-pentane 1 comma 5, both are similar, we use the term dinitrile. Understood? I hope you are able to follow this. If you have any doubt, please say this in our live session and we can discuss this further to make you understand to the maximum. Okay, so thank you.